Hello, everybody, and welcome to our lesson on trig review. This is part 2, where we're talking about the unit circle. So if we want to find exact values for sine x and cosine x, if we're already given a value for tan x, this is similar to an example we saw before. First, we need to pay attention to this. We need to see that x is between pi over 2 and pi. That means between 90 degrees and 180 degrees. So my terminal arm is rotated into this quadrant. And we're going to use the cast rule to label this all soup turns cold, okay, starting in quadrant 1. So we know in this quadrant sine is positive, but tan will be negative, as it's indicated here. So if we know that tan x is negative 4/3, we know that tan is y over x, so we know that the y is 4 and the x is negative 3. We know the negative goes with the x because of the quadrant that it's in. And if I want to write the values for sine x and cosine x, I need to also know the value of r. What is the length of this terminal arm? So I use my Pythagorean theorem because this makes a right angle triangle. And I solve for r by plugging in the values I know for x and for y. And I find out r is 5. Then I can write my ratios. Remember that sine theta can be expressed as y over r. So we just take our y value here and our r value here, 4 over 5, positive because it's in this quadrant 2. And cosine is x over r, so negative 3 over 5. One more. What about if we want to find the angles on the unit circle? And here they've indicated that we're using radians. So let's take a look at B. We want to find the angle that will give us cosine value of 0.83. So the first thing we need to do is we need to think about what is the first value of theta? What is my initial value of theta, if you like? So because they've given this to me in decimals, I can just go ahead and jump to my calculator, get cosine inverse of 0.83, and that tells me that theta must be 0.592 radians. They've also told me that cosine is positive, so I know that there's two places on the unit circle where cosine is positive. It's positive in quadrant 1, and it's positive in quadrant 4. So this 0.592 radians either goes between, it always goes between the terminal arm and the x-axis. So here the terminal arm is ending up in quadrant 1, so this is the 0.592 that I found from above. In this quadrant, just a moment, I apologize.
Your supply of masks from the main foyer, please. It's only available till 12, so we appreciate if the teachers who have not yet collected them to do so promptly now. Thank you.
Sorry for that interruption. In this, the other place where my terminal arm ends is in quadrant 4, and that 0.592 always goes between the terminal arm and the x-axis. But the angle of rotation goes all the way through these quadrants to here. So to figure out what that one is, I know that going all the way around the unit circle would be 2 pi, but I don't want to go this extra 0.592, so I subtract it and I get a theta of 5.69. Okay. Another example we'll look at is E, tan of theta equals 1.2. So tan of theta equals 1.2. If I want to know the initial value of theta, or the reference angle, I'm going to take tan inverse on my calculator and get 0.876 radians. Because tan is positive, I know that there are two options. Either tan will be in the quadrant 1 where all ratios are positive, or it'll be in quadrant 3 where only tan is positive. That 0.876 either goes between this terminal arm and the x-axis, or between this terminal arm and the x-axis. So either theta is just 0.876 radians, or it's 180 degrees, or pi radians, plus an additional 0.876 radians to give me 4.02 radians. Thank you, and have a great afternoon.